has failed. Now see here. Now this is the line where our command failed. Why? Because the expected title was not there. And if you look in the logs, it says your assert title on Amazon.in failed. Actual result was something different and it did not match with what we had asked it for. So this is how simple it is to use your IDE to create your automation scripts. So we saw all the components of IDE. We saw the record button, then I showed you the toolbar, I showed you the editor box and also the test execution log. So now let's come to what are the limitations of this IDE. With IDE, you cannot export your scripts, your test scripts to WebDriver scripts. This support is not yet added, but it is in the works. Data-driven testing, like using your Excel files or reading data from the CSV files and passing it to the script, this capability is still not available. Also, you cannot connect to database for reading your test data or perform any kind of database testing. With Selenium WebDriver, yes, you can. Also, unlike Selenium WebDriver, you do not have a good reporting mechanism with the IDE, like say for example, TestNG or ReportNG. So that brings us to the next component of the suite, which is Selenium RC, Selenium Remote Control. So Selenium RC was developed by Paul Hammond. He refactored the code which was developed by Jason and was credited with Jason as a co-creator of Selenium. Selenium Server is written in Java. It is used to write web application tests in different programming languages, as it supports multiple programming languages like your Java, C#, Perl, Python and Ruby. It interacts with the browser with the help of an RC server. So this RC server uses a simple HTTP GET and POST request for communication. And as I said earlier also, Selenium RC was called as Selenium 1.0 version. But it got deprecated in Selenium 2.0 and was completely removed in 3.0 and it got replaced by what? WebDriver. And we'll see why this happened and what was that issue which we had with the RC server. So this is the architecture of Selenium remote control at a very high level. So when Jason Huggins introduced Selenium, you know the tool was called as JavaScript program. And then that was also called as a Selenium core. So every HTML has a JavaScript statements which are executed by web browser, and there is a JavaScript engine which helps in executing this command. Now this RC had one major issue. Now what was that issue? Say for example, you have a test script, say test.javascript here, which you are trying to access elements from anywhere from the google.com domain. So what used to happen is every element which is accessible are the elements which can belong only to google.com domain. Like say for example, mail, the search or the drive. So any elements from this can be accessible through your test scripts. However, nothing outside the domain of say google.com in this case was accessible. Say for example, if your test scripts wanted to access something from yahoo.com, this was not possible. And this is due to the security reasons, obviously. Now to overcome that, the testers, what they had to do was they had to install the Selenium core and the web server which contained your web application which is under test on the same machine. And imagine if you have to do this for every machine which is under test. This is not going to be feasible or even effective all the time. And this issue is called as a same origin policy. Now what a same origin policy issue says is it prohibits a JavaScript from accessing elements or interacting with scripts from a domain different from where it is launched. And this is purely for the security measure. So if you have written a scripts which can access your google.com or anything related to google.com, these scripts cannot access any elements outside the domain. Like as we said in the example yahoo.com. This was the same origin policy. Now to overcome this, what this gentleman did was he created something called as Selenium Remote Control Server to trick the browser in believing that your core, your Selenium core and your web application under test are from the same domain. And this is what was the Selenium Remote Control. So if you look at again a high level architecture or how did this actually work, first you write your test scripts, which is here, right, in any of the supported language like your PHP or your Java or Python. And before we start testing, we need to launch this RC server, which is a separate application. So this Selenium server is responsible for receiving the Selenese commands. And these Selenese commands are the ones which you have written in your script. It interprets them and reports the result back to your test. So all that is done through your RC server. The browser interaction which happens through RC server, right, from here to your browser. So this happens through a simple HTTP and post and get request. And that is how your RC server and your browser communicate. And how exactly this communication happens? This RC server, it acts like a proxy. So say your test scripts asked to launch a browser. So what happens is this command goes to your server and then your RC server launches the browser. It injects the JavaScript into the browser. Once this is done, all the subsequent calls from your test script, right, from your test scripts to your browser goes through your RC. And now upon receiving these instructions, your Selenium core executes these actual commands as JavaScript commands on the browser. And then the test results are displayed back from your browser to your RC to your test scripts. So the same cycle gets repeated, right, until the complete test case execution is over. So for every command what you write in your JavaScript here or your test script here goes through a complete cycle of going through the RC server to the browser, collecting the results again from the RC server back to your test scripts. So this cycle gets repeated for every command until your complete test execution is done. So RC had definitely a lot of shortcomings, and what are those? So RC server needs to be installed before running any test scripts, which we just saw. So that was an additional setup since it acts as a mediator between your commands, which is your Celinese commands, and your browser. The architecture of RC is complicated. Why? Because of its intermediate RC server, which is required to communicate with the browser. The execution of commands takes very long. It is slower. We know why. Because every command in this takes a full trip from the test script to your RC server, to the core engine, to the browser, and then back to the same route, which makes your overall test execution very slow. Lastly, the APIs supported by RC are very redundant and confusing. So RC does have a good number of APIs. However, it is less object oriented. So they are redundant and confusing. Say for example, say if you want to write into a text box, how and when to use a type key command or just a type command is always confusing. Another example is some of the mouse commands, using a click or a mouse down. Both kind of, almost providing a similar functionality. So that is the kind of confusion which developers used to create. Hence, Selenium RC got deprecated and is no more available in latest Selenium versions. It is obsolete now. Now to overcome these shortfalls, WebDriver was introduced. So while RC was introduced in 2004, WebDriver was introduced by Simon Stewart in 2006. It's a cross-platform testing platform, so WebDriver can run on any platform like say Linux, Windows, Mac, or even if you have a Ubuntu machine, you can run your Selenium scripts on this machine. It is a programming interface to run test cases. It is not an IDE. And how does this work actually? So test cases are created and executed using web elements or objects using the object locator and the WebDriver methods. So when I do a demo, you will understand what these WebDriver methods are and how do we locate the web elements on the web page. It does not require a core engine like RC. So it is pretty fast. Why? Because WebDriver interacts directly with the browser and it does not have that intermediate server like the RC had. So each browser, in this case, what happens is each browser has its own driver on which the application runs. And this driver is responsible to make the browser understand the commands which you will be passing from the script. Like say for example, click of a button or you want to enter some text. So through your script, you tell which browser you want to work with, say Chrome, and then the Chrome driver is responsible for interpreting your instructions and to execute it on the web application launched on the Chrome browser. So like RC, WebDriver also supports multiple programming languages in which you can write your test scripts. So another advantage of WebDriver is it supports various frameworks like TestNG, JUnit, NUnit, and ReportNG. So when we talk about the limitations of WebDriver, you will appreciate how this support for various frameworks and tools help in making the Selenium a complete automation solution for web application. So let's look at the architecture of WebDriver at a high level. What is in WebDriver? So WebDriver consists of 4 major components. The first one is we have got client libraries, right? Or what we also call it as language bindings. So since Selenium supports multiple language and you're free to use any of the supported languages to create your automation script, these libraries are made available on your Selenium website, which you need to download and then write your scripts accordingly. So let's go and see from where do we download this. So if I go to my browser, so seleniumhq.org, right? So if you're working with Selenium, this website is your Bible. So anything and everything you need to know about Selenium, right? You need to come here. and use all the tabs here in this website. So right now what we are going to look at is what are those language bindings. So for that, I'll have to go to this download tab here. Okay. And if you scroll down here, you will see something like Selenium client and WebDriver language bindings. And for each of the supported language of Selenium, you have a download link, right? So say for example, if you're working with Java here, what you need to do is you need to download your Java language binding. So let's go back to the presentation. So this is where your language bindings are available. Next, so Selenium provides lots of APIs for us to interact with the browser. And when we do the demo, I'll be showing you some of these APIs, right? And these are nothing but the REST APIs. And everything, whatever we do through the script happens through the REST calls. Then we have a JSON wire protocol. What is JSON? JavaScript Object Notation. It is nothing but a standard for exchanging data over the web. So for example, you want to say launch a web application through your script. So what Selenium does it creates a JSON payload and posts the request to the browser driver. That is here. And then we have this browser drivers themselves. And as I said, there is a specific driver for each browser. As you know, every tool has its own limitation. So does Selenium. So let's look at what these limitations are and if there are any workarounds for them. Cannot test mobile applications requires framework like APM. Selenium is for automating web application. It cannot handle mobile applications. Mobile applications are a little different and they need its own set of automation tool. However, what Selenium provides is a support for integrating this APM tool, which is nothing but a mobile application automation tool. And using APM and Selenium, you can still achieve mobile application automation. And when do you usually need this? When your application under test is also supported on mobile devices, you would want a mechanism to run the same test cases on web browser as well as your mobile browsers, right? So this is how you achieve it. The next limitation, so when we talked about the components of Selenium, I said that with WebDriver, we can achieve only sequential execution. However, in real-time scenario, we cannot just live with this. We need to have a mechanism to run our test cases parallelly on multiple machines as well as on multiple browsers. So though this is a limitation of WebDriver, but what Selenium offers is something called as grid, which helps us achieve this. And we will see in shortly what the Selenium grid is all about. Also, if you want to know more details as how do we work with the grid, how do you want to install that grid, so do check out our video on Simplilearn website on Selenium grid. Third limitation, so limited reporting capability. So Selenium WebDriver has a limited reporting capability. It can create basic reports, but what we definitely need is a more. So it does support some tools like say TestNG, ReportNG and even Extent reports, which you can integrate with Selenium and generate beautiful reports. Powerful, isn't it? Also, there are other challenges with Selenium, like Selenium is not very good with image testing, especially for the ones which are designed for web application automation. But then we have other tools which can be used along with Selenium like AutoIt and Securely. So if you look at all this, Selenium still provides a complete solution for your automation needs. And that's the beauty of Selenium, and that is why it makes the most popular tool of today for automation. Okay, let's do a quick comparison between the Selenium RC and the WebDriver. So RC has a very complex architecture. You know why? Because of the additional RC server. Whereas due to direct interaction with the browser, WebDriver architecture is pretty simple. Execution speed. It is slower in RC and much faster in WebDriver. Why? Because in WebDriver, we have eliminated that complete layer of Selenium server, right? That the RC server, and we established a direct communication with the browser through browser drivers. It requires an RC server to interact with the browsers. We just talked about it, and whereas WebDriver can directly interact with the browser. So RC, again, we talked about this as one of the limitations, that we have a lot of redundant APIs, which kept developers guessing as which API to use for what functionality. However, WebDriver offers pretty clean APIs to work with. RC did not offer any support for headless browser, whereas in WebDriver, you do have a support for using headless browsers. Let's see the WebDriver in action now. Now for the demo, we will use this particular use case. And what this use case says is navigate to the official Simplilearn website. Then type the Selenium in search bar and click on it and click on the Selenium 3.0 training. So we are basically searching for Selenium 3.0 training on the Simplilearn website. First, let's do the steps manually and then we will go ahead and write the automation script. So let's go to my browser. On my browser, what I'll do is let me first launch the Simplilearn website. Okay, and here what my use case step says is I need to search for Selenium and click on the search button. So once I do that, it is going to give me a complete list of all kind of Selenium trainings which is available with Simplilearn. And what I'm interested in is the Selenium 3.0 training here. Once I find this on the web page, I need to go and click on that. Alright. So this is all the steps which we are going to perform in this use case. Okay. Now, so for writing the test cases, I'll be using an IDE which is Eclipse. I've already installed my Eclipse and also I have installed Selenium in this instance of my Eclipse. Alright, so if you can see the reference library folder here, you will see all the jars which are required for the Selenium to work. Next, another prereq which is required for Selenium, and that is your driver files. Now, every browser which you want to work with has its own driver file to execute your Selenium scripts. And since for this demo, I'll be working with the Firefox browser, I will need a driver file for Firefox. Now, driver file for Firefox is the Gecko driver, which I have already downloaded and placed in my folder called drivers. Now, where did I download this from? Let's go ahead and see that. So if I go back to my browser and if you go to your seleniumhq.website, you have to go to this download tab here. In the download tab, when you scroll down, you will see something like third-party drivers, bindings and plugins. In this, you will see the list of all the browsers which is supported by Selenium. And against each of this browser, you will find a link which has the driver files. Now, since we'll be using the Gecko driver, this is the link where you need to go to, and depending on which operating system which you're working on, you need to download that particular file. Now, since I'm working on Mac, this is the file which I'm using. If you're a Windows user, you need to download this zip file and unzip it. So once you unzip that, you would get a file called Gecko driver for your Firefox or a Chrome driver for your Chrome browser. And then what you do is you just create a directory called drivers under your project and just place the driver files here. So these are the two prereqs for your Selenium. One is importing your jar files like this and then having your drivers downloaded and keep them under a folder where you can reference to. Okay. So now we'll go ahead and create a class. I already have a package created in this project. So I'll use this project and create a new class. So I'll say create new Java class and let's call this as search training. I'll be using a public static void main and I'll click on finish. So let's remove this auto generated lines as we do not need them. Alright. Now the first statement which you need to write before even you start writing the rest of your code is what you need to do is you need to define or declare your driver variable using your class WebDriver. So what I would do is I'll say WebDriver driver. Done. Alright. Now you will see that this IDE is going to flash some errors for you. That means it is going to ask you to import certain libraries which is required by the WebDriver. So simply just go ahead and say import WebDriver from org.opensq.selenium. This is the package which we will need. Alright. So you have a driver created which is of the class WebDriver. And now after this I'm going to create three methods. Alright. So first method I will have for launching the Firefox browser. Okay. And then I will write a simple method for searching Selenium training and clicking on it. This is the actual use case what we'll be doing. And then third method I'm going to write is just to close the browser which I'm going to be opening, right? So these are the different methods which I'll be creating, and from the public static void main I will just call these methods one after the other. Okay, so let's go ahead and write the first method. Now my first method is launching the Firefox browser. So I'll say public void, since my return type is null or there is no return type for this, let's call it as launch browser. Okay, alright. Now in this, for launching any browser, I need to mention two steps. Now the first step is where I need to do a system.set property. Okay, let's do that first and then I'll explain what this does. I'll just say system.set property. So this accepts a key and a value pair. So what is my key here? My key here is WebDriver.gecko.driver and I need to provide a value. So value is nothing but the path to the Gecko driver. And we know that this Gecko driver, which I'm going to use here, is right here in the same project path under the drivers folder, correct? And that is what the path which I'm going to provide here. So here simply I need to say drivers slash Gecko driver. Gecko. All right, done. And let me close this sentence. All right. Now, since I'm a Mac user, my Gecko driver installable is just the name Gecko driver. If you're a Windows user and if you're running your Selenium scripts on the Windows machine, you need to provide a complete path to this, including .exe, because driver executable on your machines is going to be gecko driver.exe. All right. So just make sure that your path which you mentioned here in the system.set property is the correct path. Okay. Then the next thing what we need to do is I need to just say driver is equal to new Firefox driver. Okay. So this command new Firefox driver creates an instance of the Firefox browser. Now this is also flagging me error. Why? Because again it's going to ask me to import the packages where the Firefox driver class is present. Okay, we did that. Now these two lines are responsible for launching the Firefox browser form. So this is done. So what's my next step in the use case? Now I need to launch the website Simplilearn. So for that we have a command called driver.get. Driver.get, what it does is whatever URL you're going to give it here in this double quotes as an argument, it is going to launch that particular website. And for us, it's a Simplilearn website. So what I do as a best practice is instead of typing out the URL, I go to my browser, launch that URL which I want to test, and I simply copy it. Come back to your Eclipse and just simply paste it. So this ensures that I do not make any mistakes in the URL. Okay, so done. So our first method is ready where we are launching the browser, which is our Firefox browser, and then launching the Simplilearn website. Now, the next method. What is my next method? In my next method, I need to give the search string to search Selenium training on this particular website. Now, for that, we need to do few things. What are those few things? Let's go to the website again. All right. So let me relaunch this. Let's close this. Okay. Let me remove all this and let's go to the home page first. Okay, this is my home page. So as you saw, when I did a manual testing of this, I entered the text here. So now since I have to write a script for this, first I need to identify what this element is. For that, what I'm going to do is I'm just going to say right click here and I'll say inspect element. All right. Now this element, let's see what attribute it has, which I can use for finding this element. So I see that there is an ID present. So what I'm going to do is I'm just going to simply use this ID and then I'll just copy this ID from here. Go back to Eclipse. Let's write a method first. So I'll say public void, and what do we give the method name? Say search training or just search. All right. Now in this, I need to use a command called driver.findElement by ID is what I'm going to use as a locating technique. And in double quotes, the ID which I copied from the website is what I'm going to paste here. Okay. And then what am I going to do on this element is I need to send that text, the text which I'm going to search for, which is Selenium. So I'll just say send keys, and whatever text I want to send, I need to give it in double quotes. So for that, Selenium. So this is done. So now I've entered the text here, and after entering the text, I need to click on this button. So for that, I need to first know what that button is. So let's inspect that search button. Okay. Now, if you look at the search button, other than the tag, which is span and the class name, I do not have anything here. All right. So what I can do is I can either use the class name or I can write an XPath. Since this is a demo, which we have already used ID locating technique, I would go ahead and use the XPath here. So for me to construct an XPath, I will copy this class first. Okay. And then I already have a CrowPath installed on my Firefox. So I'll use the CrowPath and first test my XPath. So I'll just say /. Let's see what was that element. It has a span tag. Okay. So I'll have to use span and at class equal to, and I'll just copy the class name here. And let's see if it can identify that element. Yeah. So it is able to identify. So I'll just use this XPath in my code. So I'll go back to Eclipse and I'll say driver.findElement by.xpath. And the XPath which I just copied from CrowPath is what I'm going to paste here. And what is the action I need to do here? I need to say click. Done. So I have reached a stage where I've entered this Selenium. Okay. And then I have clicked on the search button. Once I do this, I know that expected result is I should be able to find this particular link here, Selenium 3.0 training. Okay, and I should be able to click on that. So for that, again, I need to inspect this. So let's inspect this Selenium 3.0. Alright, so now what are the elements this has? Now this particular element has attributes like it has a tag h2, then it has got some class name and some other attributes. So I would like to use a XPath here. Now this time, while using the XPath, I'm going to make use of a text functionality so that I can search for this particular text. So I'll simply copy this. I'll go to my crow path. The tag is h2. So I'll say simply h2. Okay. And here I'll say text equal to, and this is the text which I copied. I missed out that yes there. So I'm just going to add an S. Okay. So let's first test here whether it is able to identify that element. Yeah. So it is able to identify. So can you see a blue dotted line? It is able to show us which element it is identified. So I'll copy this XPath now and let's go to my IDE Eclipse. So now here what I need to do is I'll have to again simply say driver dot find element by dot XPath and paste the XPath which we just did, and then again I have to do a click operation. Done. Alright. So technically we have taken all the steps of the use case and we have written the commands for that. Alright. Now let's add an additional thing here. Say after coming to this page, after finding this, we want to say print the title of this page. Now what is the title of this page? If you just hover your mouse on this, it says online and classroom training for professional certification courses Simplilearn. So what I will do is after doing all these operations, I will just print out this page title on our console. So for that I have to just do this driver dot so let's do a sysout. So I'll say sysout system.out.println. Okay, and here I would say let's add a text here. The page title is, and then let's append it with driver dot get title. So this is the command which we'll be using to fetch the page title. Done. Now what is the last method I need to add? Just to close the browser. Alright, so let me add a method here. I'll say public void close browser, and it's one single command which I need to call. I'll say driver dot quit. Okay, and then I need to call all these methods from my public static void main. So let me use my class name, which is this. So I'm going to create an object obj is equal to new class name, and then using this object, first is I need to call the method launch browser, and then I'll call the method search, right, and then I'll call the method close browser. Done. So technically our script is ready with all the functionality which we wanted to cover from our use case. Now there are few other tweaks which I need to do this, and I'll tell you why I need to do this. Now for example, after we click here, right, after we click on the search, if you observed on your website, it took a little while before it listed out all the Selenium trainings for us. And usually when you're actually doing it, you wait for the Selenium 3.0 training to be available and then you click on that. Now same thing, you also need to tell your scripts to do that. You need to tell your scripts to wait for a while until you start seeing the Selenium 3.0 training or it appears on your web page. There are multiple ways to do that in your script, and it is a part of overall synchronization, what we call, where we use kind of implicit and explicit kind of ways. Now since this is a demo, for demo purpose, what I'm going to do is I'm going to use a command called thread.sleep, and I'm just going to give an explicit wait of say 3 seconds. So you can use this mainly for the demo purposes. You can use a thread.sleep command. Now this thread.sleep command needs us to handle some exceptions. So I'm just going to click on add throws declaration and say interrupted exception. Now same thing, I'll have to do it in my main function also. Okay, so let's do that and complete it. Alright, so this is done. So by doing this, what am I doing? I'm ensuring that before I click on the Selenium 3.0 training, we are giving enough time for the script to wait until the web page shows this link to the Selenium 3.0 training. That's one thing I'm doing. Alright, and also now since you're going to be seeing this demo through the video recording, the script when it starts running, it is going to be very fast. So you might just miss out seeing how it does the send keys and how did it click on the search button. For us to enable us to see it properly, I'll just add some explicit waits here just for our demo purpose. So after entering the keys, right, so what I'll do is I'll just give a simple thread.sleep here. Okay, so probably a 3 seconds or a 2 seconds wait should be good enough. Okay, a 3 seconds wait should be good enough here so that we should be able to see how exactly this works on your browser when we execute this. Okay, now our complete script is ready. So what I'll do is I'll just save the script and then we will simply run the script. So to run the script, I'll just say right click, run as Java application. Okay, it says asks me to select and save. I've saved the script now. So let's observe how it runs. Okay, the simplylearn.com, the website is launched. So the Selenium text has been entered in the search box. It has clicked on the search. Okay, all right. So now it did everything whatever we wanted it to do. All right. So since we are closing the browser, you are unable to see whether the Selenium 3.training was selected or not. However, what I have given here is to fetch the title after all these operations were complete. And if you see here, the complete operations was done and we were able to see the page title here. Okay. So now what I'll do, since we are unable to see whether it clicked on the Selenium 3.0 training or not, I'll just comment out the close browser, the command. Okay, so we will not call the close browser so that the browser remains open and we get to see whether did it really find the training link or not. Okay, so let me close this window. We don't need this Firefox window. Close all tabs and then I'll just re-execute this script. So I'll say run as Java application. So save the file. Okay, simplylearn.com is launched. So search text is entered. Now it's going to click on the search button. Yes. All right, so we have got the search results. It should click on Selenium 3.0 training and yes, it is successfully able to click on that. All right, so now it's not going to close the browser because we have commented on that line. However, it did print us the title here. All right, so this is a simple way of using the Selenium scripts. Selenium Grid. So Grid is used to run multiple test scripts on multiple machines at the same time. With WebDriver, you can only do sequential execution, but in real-time environment, you always have the need to run test cases in distributed environment. And that is where Selenium Grid comes into picture. So Grid was conceptualized and developed by Patrick. The main objective is to minimize test execution time. And how? By running your test parallelly. So design is in such a way that commands are distributed on multiple machines where you want to run test and all these are executed simultaneously. What do you achieve by this methodology? Of course, the parallel execution on different browsers and operating systems. Grid is pretty flexible and can integrate with many tools. Like say you want a reporting tool integrated to pull all the reports from the multiple machines where you're running your test cases and you want to present that report in a good looking format. So you have an option to integrate such report. Okay, so how does this grid work? So grid has a hub and node concept which helps in achieving the parallel execution. Let's take an example. Say your application supports all browsers and most of the operating systems. Like as in this picture, you could say one of them is a Windows machine, one of them is a Mac machine, and another one is say a Linux machine. So your requirement is to run the test on all supported browsers and operating systems, like the one which is depicted in this picture. So what you have to do is, first thing is you configure a master machine, or what you also call it as a hub, by running something called a Selenium standalone server. And this standalone server can be downloaded from the Selenium HQ website. Using this server, you create a hub configuration, that is this node. And then you create nodes specific to your machine requirement. And how are these nodes created? You again use the same server, which is your standalone Selenium server, to create the node configuration. So I'll show you where the Selenium server can be downloaded. So if we go back to our Selenium HQ website, so you can see here right on the top, it says Selenium standalone server.
Welcome everyone to our another demo on which we are going to see that how exactly we can do the installation of Docker on the Windows platform, specifically on Windows 10. Now Docker is something which is available for most of the operating systems, different platforms. So it supports both the Unix and the Windows platform as such. So Linux, through various commands we can do the installation, but in the case of Windows you have to download the exe file and a particular installer from the Docker Hub websites. You can simply Google it and you will get a kind of link from where you will be able to download the package. So let's go to the Chrome and try to search on for the Windows 10 particular installer. You will get a link from Docker Hub. You download it, you get the stable version, you get the Edge version, whichever version you wish to download, you can download it. So let's go back to the Chrome. So here you have the Docker desktop for Windows, so you can go for the stable or you can go for the Edge, right? So you also have the comparison that what is the difference between these two versions, right? So the particular Edge version is something which is getting releases every month, and the stable version is getting the releases every quarter, so they are not doing much of the changes to the stable version as compared to the Edge there. So you just have to double click on the installer, and that will help you to do the installation of the process. So let's get started. So you just click on the get in stable version. So when you do that, the particular installer is going to install. Now it's going to take like around 300 MB there. So that's the kind of installer which is available. So once the installer is downloaded, so what you can do is that you can actually go ahead and you can proceed with the doing the double click on this installer. When you double click on that, you have to proceed with some of the steps, like from the GUI itself you are going to proceed with these steps. So we'll wait for 10 to 20 seconds more, and then the installer will be done, and then we can do the double click and the installation will proceed. So another thing is that there is a huge difference between the installer. Like for example, in case of Unix, the installer is a little bit less, but in case of Windows, it's a GUI is also involved, and there are a lot of binaries which is available there. So that's the reason why the huge size is there. Now it's available for free, that's for sure, and it also requires the Windows 10 Professional or Enterprise 64-bit there. So if you are working on some previous version of operating systems like Windows 7 and all, you have the older version called Docker Toolbox. So they used to call it as like Docker Toolbox earlier, but now they are calling it as a Docker Desktop with the new Docker Windows 10 support as such here. So another couple of seconds and then the installer will be done, and then we will be able to proceed with the installation. So let's see that how much progress is there to the download. So we'll click on the downloads, and here still we have some particular installations or some download going on. So we'll wait for some time, and once the installation is done, then we'll go back and we'll proceed with installation. So couple of seconds. So it's almost done. So I'll just click on this one. You can go to the directory to the downloads and you can double click on that also. But if you want to do the installation, you can click on this one also, and it will ask for the approval, yes or no you have to provide. Now once that is done, so a desktop, a kind of a GUI component will open there. So it will start proceeding with the installation. So it's asking whether you want to add a desktop, the shortcut to desktop. So you can say okay. I'm going to click on OK. So it will unpack the files, all the files which is required for Docker to successfully install, that is getting unpacked over here. So it will take some time to do the installation because it's doing a lot of work here. So you can just wait for till the execution of the installer to be completed, and once the installer is done, you can open your command line and start working on the Docker. So taking some time to extract the files. Now it's asking us to do the close and do the restart. So once that is done, you will be able to proceed further, and you can just run the command line, and any Docker command if you can run, so that will give you the response whether the Docker is installed or not. So you can see here that Docker is something which is installed. So you can run like Docker version, you will be able to get a version of the client. When you do the restart of the machine, then at that moment of time the Docker server will also be started, and then this particular error message will go off. Right now the Docker daemon is not up and running because the installation requires a restart, and when you close on this one and go for the restart, the machine will be restarted here. So this is the way that how exactly we can go for a Docker installation, and we can go on that part.
So now let's begin with the demo. We'll be installing Docker on an Ubuntu system. So this is my system. I'll just open the terminal. So the first thing you can start with is removing any Docker installation that you probably already have present in your system if you want to start from scratch. So this is the command to do so. Sudo apt-get remove docker docker engine docker.io. Enter your password, and Docker is removed. So now we'll start from scratch and we'll install Docker once again. Before that, I'll just clear my screen. Okay, so before I install Docker, let me just ensure that all the softwares on my system currently is in its latest state. So sudo apt-get update. Great, so that's done. Next thing, we'll actually install our Docker. So type in sudo apt get install Docker. Now, as you can see here, there's an error that's occurred. So sometimes it's possible that due to the environment of the machine that you're working in, this particular command does not work. In which case, there's always another command that you can start with. Just type docker install. And that by itself will give you the command you can use to install Docker. So as it says here, sudo apt install docker.io is a command that we will need to execute to install Docker. And after that, we'll execute the sudo snap install Docker. So sudo apt install docker.io first. And this will install your Docker. After that's done, we will have sudo snap install Docker. So snap install Docker installs a newly created snap package. They are basically some other dependencies for Docker that you'll have to install. Of course, since this is the installation process for the entire Docker IO, it will take some time. Great, so our Docker is installed. The next thing we do, as I mentioned earlier, is that we need to install all the dependency packages. So the command for that is sudo snap install Docker. Enter your password. So with that, we have completed the installation process for Docker, but we'll perform a few more stages where we will test if the installation has been done right. So before we move on with the testing for Docker, let's once again just check the version that we have installed. So for that, the command is docker version. And as you can see, Docker version 17.12.1 CE has been installed. Next thing we do is we pull an image from the Docker Hub. So docker run hello world. Now hello world is a Docker image which is present on the Docker Hub. Docker Hub is basically a repository that you can find online. So with this command, the Docker image hello world has been pulled onto your system. So let's see if it's actually present on your system now. The command to check this is sudo docker images. And as you can see here, hello world repository, this is present on our system currently. So the image has been successfully pulled onto the system, and this means that our Docker is working. Now we'll try out another command. Sudo docker ps-a. This displays all the containers that you have pulled so far. So as you can see here, there are 3 hello world images displayed, and all of them are in exited state. So I did this demo previously too, which is why the 2 hello worlds which is created 2 minutes ago is also displayed here. And the first hello world which has been created a minute ago is the one we just did for this demo. Now, as you have probably noticed that all the Hello World images over here, all these containers are in the exited state. So when you give the option for Docker ps-a, where -a stands for all, it displays all the containers whether they are in exited or running state. If you want to see only those containers which are in their running state, you can simply execute sudo docker ps. Sudo docker ps. And as you can see, no container is visible here because none of them are in running state.
In this presentation, we're going to go through a number of key things. We're going to compare Docker versus traditional virtual machines and what are the differences and why you'd want to choose Docker over a virtual environment. We'll go through the advantages of working with Docker and the structure and how you would build out a Docker environment. And during that structure, we'll dig through the components and the advanced components within Docker. At the end of the presentation, we'll go through some basic commands and then show you how those basic commands can be used in a live demo. So with all that said, let's get started. So let's first of all compare Docker with a traditional virtual machine. So here we have the architecture on the left and right of a traditional virtual machine versus a Docker environment. And there are some things that you'll probably see immediately that are big differences. One is that the virtual environment has hypervisor layer, whereas the Docker environment has a Docker engine layer. And then in addition to that, there are additional layers within the virtual machine. Each of these really start compounding and creating very significant differences between a Docker environment and a virtual machine environment. So with a virtual machine, the actual memory usage is very high, whereas with a Docker environment, the memory usage is very low. If we look at performance, virtual machines, when you start building out particularly more than one virtual machine on a server, the performance starts degrading and starts getting poorer, whereas with Docker, the performance always stays really good. And this is largely due to the lightweight architecture used to construct the Docker containers themselves. If we look at portability, virtual machines just are terrible for portability. They're still dependent on the host operating system, and there's just a lot of problems that happen when you are using virtual machines for portability. In contrast, Docker was designed for portability, so you can actually build solutions in a Docker container environment and have the guarantee that the solution will work as you have built it, no matter where it's hosted. Finally, boot up time. The boot up time for a virtual machine is fairly slow in comparison to the boot up time for a Docker environment, which is almost instantaneous. So we look at these in a little bit more detail. One of the other challenges that you have with a virtual machine is that if you have unused memory within the environment, you cannot reallocate that memory. So if you set up an environment that has 9 gigs of memory that's being used, but you have 6 gigs that are free, you can't do anything with it. Though that whole 9 gig has been allocated to that virtual machine. In contrast with Docker, if you have 9 gigs and 6 gigs becomes free, that free memory can then be reallocated and reused across other containers used within that Docker environment. Another challenge is running multiple virtual machines in a single environment can lead to instability and performance issues, whereas Docker is designed to run multiple containers in the same environment and actually gets better the more containers you run in that hosted single Docker engine. Portability issues with a virtual machine is the software can work on one machine, but then when you move that VM to another machine, suddenly some of the software won't work because there are some dependencies that haven't been inherited correctly. Whereas Docker itself is designed specifically to be able to run across multiple environments and to be deployed very easily across systems. And again, the actual boot up time for a VM, it just takes a long time. You're talking about minutes in contrast to the milliseconds that it takes for a Docker environment to boot up. So let's dig into what Docker actually is and what allows for these great performance improvements over a traditional VM environment. So Docker itself is an OS virtualized software platform, and it allows IT organizations to really easily create, deploy, and run applications as what are called Docker containers that have all of the dependencies within that container very easily. And the container itself is really just a very lightweight package that has all the instructions and dependencies such as frameworks, libraries, bins, etc., all within that container. And that container itself can then be moved from environment to environment very easily. If we were to look in our DevOps lifecycle, the place where Docker really shines is in deployment, because when you're actually at the point of deploying your solution, you want to be able to guarantee that the code that has been tested will actually work in the production environment. But in addition to that, what we often find is that when you're actually building the code and you're actually testing the code, having a container running the solution at those stages is also a really good plus, because what happens is that the people building the code and testing the code are able to validate their work in the same environment that would be used for the production environment. So really, you can use Docker in multiple stages within your DevOps cycle, but it becomes really valuable in the deployment stage. So let's look at some of the key advantages that you have with Docker. Some of the things that we've already covered is that you can do rapid deployment, and you can do it really fast. The environment itself is highly portable and was designed for that in mind. The efficiencies that you'll see will allow you to run multiple Docker containers in a single environment as compared to more traditional VM environments. The configuration itself can be scripted through a language called YAML, which allows you to be able to write out and describe the Docker environment that you want to create. This in turn allows you to be able to scale your environment very, very quickly. But with all of these advantages, probably the one that is most critical to the type of work that we're doing today is security. You have to ensure that the environment you are running is a highly secure but highly scalable environment. And I'm very pleased to say that Docker takes security very seriously. So you'll see it as one of the key tenets for the actual architecture of the system that you're implementing. So let's look at how Docker actually works within your environment. So Docker works, there is what's called a Docker engine. The Docker engine is really comprised of the two is via REST API. The server, as you can imagine, has the instructions that are communicated out to the client and instructs the client on what to do. The connection between the client and the server, the communication is via a REST API. On older systems, you can take advantage of the Docker toolbox, which allows you to go ahead and control the Bean, Docker Compose, and Kitematic. So let's now go into what the actual root components, though, of Docker are. So let's have a look at those key components. There are 4 components that we're going to go through. We have the Docker client and server, we have Docker images, we have the Docker registry, and the Docker container. We're going to step through each of these one by one. So let's look at the Docker client and server first. So the Docker client and server is a command line instructed solution where you would use terminal on your Mac or command line on your PC or Linux system to be able to issue commands from the Docker daemon. The communication between the Docker client and the Docker host is via a REST API. So a pull command, which would send an instruction to the daemon, which would then form the interaction of pulling in the correct components such as an image or container or registry to the Docker client. The Docker daemon itself is actually a service which actually performs all sorts of operating and performance services. And as you'd imagine, the Docker daemon is constantly listening across the REST API to see if it needs to perform any specific requests. If you want to trigger and start the whole process, what you want to do is use the command daemon, and that will start all of your performances. And then you have a Docker host, which actually runs the Docker daemon and registry itself. So now let's look into the actual structure of a Docker image. So a Docker image itself is a template which contains instructions for the Docker container. And that template is written with a language called YAML. And YAML stands for yet another markup language. It's very easy to learn. The Docker image itself is built within that YAML file and then hosted as a file in the Docker registry. The image is really comprised of several key layers. And you start with your base layer, which will typically have your base image. In this instance, it's your base operating system, such as Ubuntu. And then you would then have layer of dependencies above that. This would then comprise the instructions in a read-only file that would become your Docker file. So let's actually go through and look at what one of those sets of instructions would look like. So here we have 4 layers of instructions. We have a from, pull, run, and then command. So what does that actually look like in our layers? So to break this down, the from creates a layer which is based on Ubuntu. And then what we're doing is we're adding in files from the Docker repository onto that base command, that base layer. And then what we want to be able to do is then say, okay, what are the run commands so we can actually then build the container within the environment. And then we want to be able to then have a command line that actually executes something within that container. And in this instance, the command is to run Python. So one of the things that we will see is that as we set up multiple containers, each new container is a new layer with new images within the Docker environment. Each container is completely separate from the other containers within your Docker environment. So you're able to create your own separate read-write instructions within each layer. What's interesting is that if you delete a layer, then the layer above it will also get deleted. So what happens when you pull in a layer, but something has changed in the core image? What's interesting then is that the actual main image of itself cannot be modified. Once you've copied the image, you can then modify it locally, but you can never modify the actual base image itself. So here are some callouts for the components within a Docker image. So the base layer are in read-only format. The layers can be combined in a union file system to create a single image. The union file system saves memory space by avoiding duplication of files. And this allows a file system to appear as a writable, but without modifying the file, which is known as a copy on write. The actual base layers themselves are read-only. So to be able to get around this structure within a Docker container, the Docker environment itself uses what's known as a copy on write strategy within the images and the containers themselves. And so what this allows you to do is you can actually copy the files for better efficiency across your entire container environment. The copy and write strategy does make Docker super efficient, and what you're able to do all the time is keep reducing the amount of disk space you're using and the amount of performance that you're taking from the server. And that's really, again, a key element for Docker, is just this constant ability to be able to keep improving the efficiency within the actual system itself. All right, so let's go on to item number 3, which is the Docker registry. So the Docker registry itself is the place where you would host and distribute the different types of images that you have created or you want to be used within your environment. The actual repository itself is just a collection of Docker images, and those Docker images are built on instructions that you would write with YAML and are very easily stored and shared. And what you can actually do is you can actually associate specific name tags to the actual Docker images themselves. So it's easy for people to be able to find and share that image within the Docker registry itself. One of the things you actually see as we go through the demos, you actually see us actually using the tag name, and you'll see how it is an alphanumeric identifier and how we actually use it to actually create the actual container itself. One of the things you can do to as start off how you would manage a registry is you can actually use the publicly accessible Docker Hub registry, which is available to anybody, but you can also create your own registry for your own use internally. The actual registry that you create internally can have both public and private images that you create, and this may be for various reasons of how you structure your environment. The actual commands you would use to actually connect to the registry are both push and pull. Push is to actually push a new container environment that you've created from your local manager node to the remote registry, and a pull allows you to pull a new client that has been created and is being shared. So again, pull command, it pulls and retrieves a Docker image from the Docker registry, and makes it very easy for people to share different images consistently across teams. And a push command allows you to take a new command that you've created, a new container that you've created, and push it to the registry, whether it's Docker Hub or whether it's your own private registry, and allow it to be shared across your teams. Some key did you knows in Docker registry: deleting a repository is not a reversible action. So if you delete a repository, it's gone. So let's go into the final stage here, which is the actual Docker container itself and its dependencies bundled together. So it gives instructions that you would have for the solution that you're looking to run. It's actually really light because of the redundancy that's built into how you structure the container. And the container itself is then inherently also extremely portable. What's really good about running a container, though, is that it does run completely in isolation. So you're able to share it very easily from group to group, and you are guaranteed that even if you are running a container, it's not going to be impacted by any host OS peculiarities or unique setups as you would have in a VM or a non-containerized environment. The actual memory that you have on a Docker environment, they can be shared across multiple containers, which is really useful. Typically, when you have a VM, you would have a defined amount of memory for each VM environment. The challenge you start running into, though, is that you can't share that memory, whereas with Docker, you can easily share the memory for a single environment across multiple containers. The actual container is built using Docker images, and the command to actually run those images is a run command. So let's actually go through a basic structure of how you would run a Docker image. So you go into terminal window and you would write in Docker run Redis, and then it would run a container called Redis. So we're going to go in, and if you don't have the Redis image locally installed, it will then pull it from the registry. Then the new Docker container Redis will be then available within your environment, so you can actually start using it. So let's look at why containers are so lightweight. They're so lightweight because they really have been able to get away from some of the additional layers that you have in virtualization within VMs. And the biggest one is the hypervisor and the need to run on a host operating system. Those are two big elements. So if you can get rid of those, then you're doing great. So let's look at some of the more advanced concepts within the Docker environment. And we're going to look at two advanced components. One is Docker Compose, and the second is Docker Swarm. So let's look at Docker Compose. Docker Compose is really designed for running multiple containers as a single service. And it does this by running each container in isolation, but allowing the containers to interact with each other. As was stated earlier on, you would actually write the Compose environment using YAML as the language in the files that you would create. So where would you use something like Docker Compose? So an example would be if you are running an Apache server with MySQL database and you need to create additional containers to run additional services without the need to start each one separately. And this is where you would write a set of files using Docker Compose to be able to help balance out that demand. So let's now look at Docker Swarm. So Docker Swarm is a service that allows you to be able to control multiple Docker environments within a single platform. So what you actually are looking at doing is within your Docker Swarm is we're treating each node as a Docker daemon, and we're actually having an API that's interacting with each of those nodes. There are two types of node that you're going to be getting comfortable working with. One is the manager node, and the second is the worker node. And as you'd expect, the manager node is the one sending out the instructions to all of the worker nodes. But there is a two-way communication that is happening. The communication allows for the manager node to be able to manage the instructions and then listen to and receive updates from the worker node. So if anything happens within this environment, the manager node can react and adjust the architecture of the worker node so it's always in sync. It was really great for large scaled environments. So finally, let's go through what are some of the basic commands you would use within Docker. And once we've gone through all these basic commands, we'll actually show you a demo of how you'd actually use them as well. So if we're going to go in, probably the first command is to install Docker. And so if you have yum installed, you just do yum install Docker, and you'll install Docker onto your computer. To start the Docker daemon, as you want to do systemctl start Docker. The command to remove a Docker image is docker rmi and then the image ID itself. And that's not the image name, that's the actual alphanumeric ID number that you want to grab. The command line to download a new image is docker pull and then the name of the image you'd want to pull. And by default, you're going to be pulling from the Docker default registry that will then connect to your Docker daemon and download the images from that registry. The command line to run an image is docker run and then the image ID. And then we have if we wanted to pull specifically from Docker Hub, then we would have docker pull and then the image name and colon its tag. To build an image from a Docker file, you would do docker build-t and then the image name and colon tag. To shut down the container, you would do docker stop container ID. The access for running a container is docker exec it container ID bash. So we've gone through all the different commands, but let's actually see how they would actually look, and we're going to go ahead and do a demo. So welcome to this demo where we're going to go ahead and put together all of the different commands that we have outlined in the presentation for Docker. First is just to list all of the Docker images that we have. So we do sudo docker images and we enter in our password. And this will now list out the images that we've created already. And we have 3 images there. So let's go ahead and pull a Docker image. So to do that, we'll go ahead and type sudo docker. And actually, we don't want to do image. We want to select pull and then the name of the image that we want to pull, which is going to be MySQL. And by default, this is actually going to go ahead and use the latest MySQL command, MySQL image that we have. So it's now going to go ahead and pull this image. It's going to take a few minutes depending on your internet connection speed. It's kind of a large file that has to be downloaded. So we'll just wait for that to download. You can see the others have completed. Just waiting for this last file to download. Almost there. Once that's done, what we're going to go ahead and do is we'll actually run the Docker container and create the new container using the image that we just downloaded. But we have to wait for this to download first. Alright, so the image has been pulled from Docker Hub. And let's go ahead and create the new Docker container. So we're going to do sudo docker run -d -p 0.0.0.0 :80 :80, and then we'll put in MySQL latest, so we have the latest version, and we have our new token, and that shows our new Docker container has been created. Now let's go ahead and see if the container is running, and we'll do sudo docker.
Lot of updation in the operating code needs to be updated at first, and as the requirements of the company change, the infrastructure's configuration needs to change. And finally, of course, the people need coordination. So if you have a team of system administrators and say person A makes some change to the code, person B, C, D and so on need to be well aware when the change is made as to why it was made, what was the change made, and where exactly this change was made. So that here the nodes pushes these files onto the node. So the complete control lies with the server. On your right side, we have the pull configuration. In case of pull configuration, the nodes poll against the server to first check if there's any change in the configurations required. If there is, the nodes themselves pull these configuration files. Chef follows pull configuration, and how it does this, we'll see further in our video. Another important term often used with Chef, infrastructure as code. So let's understand what this term infrastructure as code means through this small story. So here's Tim. Tim's a system administrator at a large company. Now he receives a task. He has to set up a server and he has to install 20 software applications over it. So he begins. He sets up the server, but then it hits him. It would take him the entire night to install 20 software applications. Wouldn't things have been much simpler if he just had a code to do so? Well, of course, codes do make things much simpler. Codes have a number of advantages. They're easily modifiable. So if today Tim is told we need MySQL installed on 20 systems. Tim simply writes a code to do so. And the very next day Tim is told, we changed our mind. We don't need MySQL. I think we'll just use Oracle. This does not bother Tim because now he just opens the file, he makes a few corrections in his code, and that should work just fine. Code is also testable. So if Tim had to write 10 commands to do something, and at his 10th command he realized the very first command he wrote, there was something not right there. Well, that would be quite tiresome, wouldn't it? With codes, however, you can test it even before running it, and all the bugs can be caught and corrected. Codes are also deployable. So they're easily deployable, and they're deployable multiple times. So now that we saw the various advantages of having codes, let's see what infrastructure as code exactly is. Here's the definition. Infrastructure as code is a type of IT infrastructure where the operation team manages the code rather than a manual procedure. So infrastructure as a code allows the operations team to take care of a code which automatically performs various procedures rather than having to manually do those procedures. So with this feature, all your policies and your configurations are written as code. Let's now look at the various components of Chef. So our first component is the workstation. The workstation is the system where the system administrator sits. He or she creates the codes for configuring your nodes. Now these codes, which in case of Chef are written in Ruby, are called the recipes. And you'll have multiple number of recipes. So a collection of recipes is called a cookbook. Now these cookbooks are only created at the workstation, but they need to be stored at the server. So the knife is a command line tool. So it's basically a command that you will see us executing in one of our demos that shifts these cookbooks from the workstation over to the server. A second component is the server. So server is like the middleman. It lies between your workstation and your nodes. And this is where all your cookbooks are stored. Because as you saw previously, the knife sends these cookbooks over from the workstation to the server. The server can be hosted locally, that's on your workstation itself, or it can be remote. So you can have your server at a different location. You can even have it on the cloud platform. And a final component, the node. So nodes are the systems that require the configuration. In a Chef architecture, you can have a number of nodes. Ohai is a service which is installed on your node, and it is responsible for collecting all the information regarding your current state of the node. This information is then sent over to the server to be compared against the configuration files and check if any new configuration is required. Chef Client is another such service on your node which is responsible for all the communications with the server. So whenever the node has a demand for a recipe, the Chef Client is responsible for communicating this demand to the server. Since you have a number of nodes in a Chef architecture, it's not necessary that each node is identical. So of course, every node can have a different configuration. Let's now have a look at the Chef architecture. So here we have a workstation, one server machine, and 2 nodes. You can have any number of nodes. First things first, the system administrator must create a recipe. So the recipes that are mentioned in our Chef architecture are just dummy recipes. We'll look into actual functioning recipes later in our demo. So you have 1 recipe, 2 recipes, 3 recipes, and a collection of recipes forms a cookbook. So guys, if you look at the recipe, in source you have simply learn 3.erb. ERB is the extension for your Ruby files. So the cookbooks are only created at the workstation. They now need to be sent over to the server where they are stored. And this is the task of the knife. Knife is a command line tool which is responsible for transferring all your cookbooks onto the server from the workstation. Here's the command for running your knife. Knife upload simply-db, where simply-db is the name of the cookbook. We then move on to our node machines. At our nodes, we run the Ohai service. The Ohai service will collect all information regarding the current state of your nodes and send it over to the Chef client. When you run the Chef client, these informations are sent over to the server and they are tested against the cookbooks. So if there is any discrepancy between the current state of your nodes and the cookbook, that is, if one of the nodes does not match the configurations required, the cookbook is then on the server and executed at the node. This sets the node to the right state. There are various flavors of Chef. We'll go through these. First, we have Chef Solo. With Chef Solo, there's no separate server, so your cookbooks are located on the node itself. Now this kind of configuration is used only when you have just a single node to take care of. The next flavor is a hosted chef. With Hosted Chef, you still have your workstation and your node, but your server is now used as a service on the cloud. This really makes things simple because you don't have to set up a server yourself and it still performs all the functioning of a typical chef. This is the configuration you will notice that we'll be using in our demo. Chef Client Server. With Chef Client Server, you have a workstation, you have server, and you have n number of nodes. Now, this is the traditional chef architecture. This is the one we have used for all the explanations previously. And finally, we have Private Chef. Private Chef is also known as Enterprise Chef. In this case, your workstation, server, and node all are located within the enterprise infrastructure. This is the main difference between Chef Client Server and Private Chef. In case of Chef Client Server, all these three machines could be dispersed. The enterprise version of Chef also provides the liberty to add extra layers of security and other features. And we reach the final part of our video where we'll have the hands-on. So before we dive into our demo, let me just quickly give you an introduction to it. We'll be using two virtual boxes, both CentOS 7. One will be used as a workstation while the other will be a node. So we are just using one node to make things simple. The server will be used as a service on the cloud. Now these are the steps we'll be performing during our demo. We'll first download and install the Chef DK on our workstation. We then make an empty cookbook file and we'll write a recipe into it. We need to then set up the server. So as I mentioned earlier, server will be a service on the cloud. So you'll have to create a profile, but this will be completely free. We then link the workstation to the server and will upload the recipe to the server. The nodes will now download the cookbooks from the server and configure themselves. So now that you have some idea about what we'll be doing, let's move on to the actual demo. We begin our demo. Here's my Oracle VM VirtualBox Manager. I have two machines here. I've already created my workstation and node. Both of these are CentOS 7 machines. Just for you to differentiate, this is my terminal. And for my workstation, it's a black background with white text. And as of my node, it's a black background with green text. The first thing you do is you go to your workstation box and open a web browser. Search for Chef DK installation. Go to the first link, which is your Chef's official page. A very warm welcome to all our viewers. I'm Anjali from Simplilearn, and today I'll be showing you how you can install the configuration management tool Ansible. So let's have a brief about why one would use Ansible and what exactly is Ansible. So if you consider the case of an organization, it has a very large infrastructure, which means it has more than probably hundreds of systems. And giving one or even a small team of people the responsibility to configure all these systems makes their work really tough, repetitive, and as you know, manual work is always prone to errors. So Ansible is a tool which can automate the configuration of all these systems. With Ansible, a small team of system administrators can write simple codes in YAML, and these codes are deployed onto the hundreds and thousands of servers, which configures them to the desired states. So Ansible automates configuration management, that is configuring your systems. It automates orchestration, which means it brings together a number of applications and decides an order in which these are executed, and it also automates deployment of the applications. Now that we know what Ansible does, let's move on to the installation of Ansible. So here is my Oracle VM VirtualBox Manager. I'll be using two systems. There's the node system, which is basically my client system, and there's the server system or the master system. So let's begin at our server system. So this is my master system, guys. So the first thing we do is we download our Ansible tool. So one or Puppet, Ansible is a push type of configuration management tool. So what this means is that the entire control here lies with your master or your server system. This is where you write your configuration files, and these are also responsible for pushing these configuration files onto your node or client system as and when required. Great, so our Ansible tool is installed. Now we need to open an Ansible host file. and there we'll specify the details of our node or client machine. So this is our Ansible host file. As you can see here, the entire file is commented, but there's a certain syntax that you'd observe. For example, here we have a group name, web servers, under which we have the IP addresses or certain host name. So this is about how we'll be adding the details for our client system. First, we need to give a group name. Under this group, basically, we add all the clients which require a certain type of configuration. Since we are using just one node, we'll give only the details for that particular node. First, we need to add the IP address of our client machine. So let's just go back to our client machine. And this here is the IP address 192.168.2.11. Once you have typed in your IP address, give a space and then we'll specify the user for our client machine. So all communications between the server or the master system and the client or the node system takes place through SSH. SSH basically provides a secure channel for the transfer of information. Follow this up with your password. In my case, it's the root's password. And that's it, we are done. So now we save this to our terminal. So now that our host file is written, the next thing we do is we write our playbook. So playbook is the technical term used for all the configuration files that we write in Ansible. Now playbooks are written in YAML. YAML is extremely simple to both write and understand. It's in fact very close to English. YAML first starts with 3 dashes. This indicates the beginning of your file. Next thing, we need to give a name to our playbook. So name, and I'm going to name my playbook sample book. We next need to specify our host systems, which is basically the systems at which the configuration file, or the playbook in our case, will be executed. So we'll be executing this at the client machines mentioned under the group Ansible servers. So we had just one client machine under it. We'll still mention the group name. We next need to specify the username with which we'll be logging into our client machine, which is root in my case. And become true specifies that you need to become the root to execute this playbook. So becoming the root is called a privilege escalation. Next, we need to specify our tasks. So these are basically the actions that the playbook will be performing. So you would have noticed everything so far is aligned, that is name, host, remote user, become and task, because these are at one level. Now whatever comes under task will be shifted slightly towards the right. Although YAML is extremely simple to understand and read both, it's a little tricky while writing because you need to be very careful about the indentations and the spacing. So my first task is install HTTPD, which is basically an Apache server. So now my command's yum, and this will be installing the HTTPD package. And the latest state of it will be installed. So that's our first task. Now our second task would be running our Apache service. So name, run HTTPD, and the action, which is service, will be performed on HTTPD, hence the name HTTPD, and state must be started. Now we come to our third task. So here we'll create a very simple web page that will be hosted. So create content is the name of our task. And the content that we are creating here will basically be copied to our node system at a particular file location that we'll provide. Our content will be congrats. And then we'll provide the destination at which this file will be copied. So this is the default location for all our HTML files. And that's it. We are done writing our playbook. Just save this and go back to your terminal. Before we execute the playbook or push the playbook onto our node system, let's check the syntax of our playbook. So the command for doing so is, and if everything's fine with your playbook, the output would be just your playbook name. So our syntax is perfectly fine. Now we can push on the playbook to our node or the client machine. and that's the syntax for doing so. Now, as your playbook is being sent over to the client machine, you can see that first the facts are gathered. That is, the current state of your client machine is first fetched to check what all is to be changed and what is already present. So the first thing is installing HTTPD. So our system already had HTTPD. So it says OK, because this does not need to be changed. Our next task was running HTTPD. Now, although our system had the Apache service, it was not running. So that is one thing that was changed. The next was there was no content available. So the content was also added. So 2 tasks were changed and 4 things were okay. Now, everything seems fine. And before you move any forward, it is very important that you check this one line of documentation provided by Ansible. You have all kind of information available here regarding which all tasks were executed, if your client machine was reachable or unreachable, and so on. So now that everything's fine here, we can move on to our node system and we'll just go to our browser. So if our playbook has been executed here, what should happen is that the HTTPD service must be in the running state and the web page that we created should be hosted. So let's just type localhost. And great, everything's working fine. So our web page is displayed here. So we come to an end for our installation and configuration video for the configuration management tool Ansible. If you have any doubts, please post them in the comment section below and we'll definitely get back to you as soon as possible.
Ansible today as one of the key tools that you would have within your DevOps environment. So the things that we're going to go through today is we're going to cover why you would want to use a product like Ansible, what Ansible really is and how it's of value to you in your organization, the differences between Ansible and other products that are similar to it on the market and what makes Ansible a compelling product. And then we're going to dig into the architecture for Ansible. We're going to look at how you would create a playbook, how you'd manage your inventory of your server environments, and then what is the actual workings of Ansible. As a little extra, we're going to also throw in Ansible Tower, one of the secret source solutions that you can use for improving the speed and performance of how you create your Ansible environments. And finally, we're going to go through a use case by looking at Hootsuite, a social media management company, and how they use Ansible to really improve the efficiency within their organizations. So let's jump into this. So the big question is, why Ansible? So you have to think of Ansible as another tool that you have within your DevOps environment for helping manage the servers. And this definitely falls on the operations side of the DevOps equation. So if we look here, we have a picture of Sam, and like yourselves, Sam is a system administrator, and he is responsible for maintaining the infrastructure for all the different servers within his company. So some of the servers that he may have that he has to maintain could be web servers running Apache, they could be database servers running MySQL. And if you only have a few servers, then that's fairly easy to maintain. I mean, if you have 3 web servers and 2 database servers, and let's face it, wouldn't we all love just to have 1 or 2 servers to manage? It would be really easy to maintain. The trick, however, is as we start increasing the number of servers, and this is a reality of the environments that we live and operate in, it becomes increasingly difficult to create consistent setup of different infrastructures such as web servers and databases, for the simple reason that we're all human. As if we had to update and maintain all of those servers by hand, there's a good chance that we would not set up each server identically. Now, this is where Ansible really comes to the rescue and helps you become an efficient operations team. Ansible, like other system solutions such as Chef and Puppet, uses code that you can write and describe the installation and setup of your servers. So you can actually repeat it and deploy those servers consistently into multiple areas. So now you don't have to have one person redoing and refollowing setup procedures. You just write one script and then each script can be executed and have a consistent environment. So we've gone through why you'd want to use Ansible. Let's step through what Ansible really is. So, this is all great, but, how do we actually use these tools in our environment? So Ansible is a tool that really
node, and then within quotes, insert the host name of your node system. So my node system's host name is client, the package you wish to install, which in our case is HTTPD, and the action to be performed. And that's it. A very small and simple code. Save this file. Now let's go back to our node system and let's pull this second version of the same configuration file. So every time you execute this command, as we did previously too, what happens is that the agent service, so the agent service basically checks on your master system if there's any new configuration file added or if there's any change to the previous configuration file made. If so, then the catalog is applied once again. So now our catalog is applied in 1.55 seconds. So now to check if our catalog served its purpose, let's just open our browser. Just type localhost here. And as you can see, if your HTTPD package has been successfully installed, the Apache testing page will appear here.
So in this session, what we're going to do is we're going to cover what and why you would use Puppet. What are the different elements and components of Puppet and how does it actually work? And then we'll look into the companies that are adopting Puppet and what are the advantages that they have now received by having Puppet within their organization. And finally, we'll wrap things up by reviewing how you can actually write a manifest in Puppet. So let's get started. So why Puppet? So here is a scenario that as an administrator, you may already be familiar with. You as an administrator have multiple servers that you have to work with and manage. So what happens when a server goes down? It's not a problem. You can jump onto that server and you can fix it. But what if the scenario changes and you have multiple servers going down? So here is where Puppet shows its strength. With Puppet, all you have to do is write a simple script that can be written with Ruby and write out and deploy to the servers your settings for each of those servers. The code gets pushed out to the servers that are having problems, and then you can choose to either roll back to those servers to their previous working states or set them to a new state and do all of this in a matter of seconds. And it doesn't matter how large your server environment is, you can reach to all of these servers. Your environment is secure, you're able to deploy your software, and you're able to do this all through infrastructure as code, which is the advanced DevOps model for building out solutions. So let's dig deeper into what Puppet actually is. So Puppet is a configuration management tool. Maybe similar tools like Chef that you may already be familiar with. It ensures that all your systems are configured to a desired and predictable state. Puppet can also be used as a deployment tool for software. Automatically, you can deploy your software to all of your systems or to specific systems. And this is all done with code. This means you can test the environment and you can have a guarantee that the environment you want is written and deployed accurately. So let's go through those components of Puppet. So here we have a breakdown of the Puppet environment. And on the top, we have the main server environment. And then below that, we have the client environment that would be installed on each of the servers that would be running within your network. So if we look at the top part of the screen, we have here our Puppet master store, which has and contains our main configuration files. And those are comprised of manifests that are actual codes for configuring the clients. We have templates that combine our codes together to render a final document. And you have files that would be deployed as content that could be potentially downloaded by the clients. Wrapping this all together is a module of manifest templates and files. You would apply a certificate of authority to sign the actual documents so that the clients actually know that they're receiving the appropriate and authorized modules. Outside of the master server where you'd create your manifest templates and files, you would have Puppet Client is a piece of software that is used to configure a specific machine. There are two parts to the client. One is the agent that constantly interacts with the master server to ensure that the certificates are being updated appropriately. And then you have the factor, that the current state of the client that is used and communicated back to through the agent. So let's step through the workings of Puppet. So the Puppet environment is a master-slave architecture. The clients themselves are distributed across your network and they are constantly communicating back to a master server environment where you have your Puppet modules. The client agent sends a certificate with the ID of that server back to the master. And then the master will then sign that certificate and send it back to the client. And this authentication allows for a secure and verifiable communication between client and master. The factor then collects the state of the client and sends that to the master. Based on the facts sent back, the master then compiles manifests into the catalogs, and those catalogs are sent back to the clients, and an agent on the client will then initiate the catalog. A report is generated by the client that describes any changes that have been made and sends that back to the master, with the goal here of ensuring that the master has full understanding of the hardware running software in your network. This process is repeated at regular intervals, ensuring all client systems are up to date. So let's have a look at companies that are using Puppet today. There are a number of companies that have adopted Puppet as a way to manage their infrastructure. So companies that are using Puppet today include Spotify, Google, AT&T. So why are these companies choosing to use Puppet as their main configuration management tool? And the answer can be seen if we look at a specific company. Staples. So Staples chose to take and use Puppet for their configuration management tool and use it within their own private cloud. The results were dramatic. The amount of time that the IT organization was able to save in deploying and managing their infrastructure through using Puppet enabled them to open up time to allow them to experiment with other and new projects and assignments, a real tangible benefit to a company. So let's look at how you write a manifest in Puppet. So manifests are designed for writing out in code how you would configure a specific node in your server environment. The manifests are compiled into catalogs, which are then executed on the client. Each of the manifests are written in the language of Ruby with a .pp extension. Now, if we step through the 5 key steps for writing a manifest, they are: 1. Create your manifest, and that is written by the system administrator. 2. Compile your manifest, and it's compiled into a catalog. 3. Deploy. The catalog is then deployed onto the clients. 4. Execute. The catalogs are run on the client by the agent. And clients are configured to a specific and desired state. If we actually look into how a manifest is written, it's written with a very common syntax. If you've done any work with Ruby or really configuration of systems in the past, this may look very familiar to you. So we break out the work that we have here. You start off with a package, file, or service as your resource type, and then you give it a name, and then you look at the features that need to be set, such as IP address. Then you're actually looking to have a command written, such as present or start. The manifest can contain multiple resource types. If we continue to write our manifest in Puppet, the default keyword applies a manifest to all clients. So an example would be to create a file path that creates a folder called sample in a main folder called etc. The specified content is written into a file that is then posted into that folder. And then we're going to say we want to be able to trigger an Apache service, and then ensure
environment that you're looking to manage that will determine which of these 4 tools you should use. The tools themselves are open source, so go out and experiment with them. There's a lot of videos. Our team has done a ton of videos on these tools, and so feel free to find out other tools that we have and covered so you can learn very quickly how to use them. But consider the requirements that you have and consider the capabilities of your team. If you have Ruby developers or you have someone on your team that knows Ruby, your ability to choose a broader set of tools becomes much more interesting. If, however, you're new to coding, then you may want to consider YAML-based tools. Again, the final answer is going to be up to you, and we'll be really interested on what your decision is.
Monitoring, as the term says, you're monitoring, you're watching, you're logging your production environment. So of course there are a whole bunch of monitoring tools, so they become an important part of your production environment. And a lot of these monitoring tools are also, I've seen them also being used, especially in your UAT environment. And you can optionally have them for some time, even in your, development environment. No, not development. Because development servers are usually not very high-end configurations. But maybe a decent development / integration server, especially if you have long-running scripts and if you have programs that use a lot of servers, maybe CPU or processing power. So then you can have monitoring tools when you're writing such scripts and you're doing the unit testing for those scripts, so that to see what kind of server utilization happens when you run this script. If you'll put this in production, will it actually slow down your production server, and what kind of impact that will have on the your rest of your application or other applications running on that server. But this particular chapter is more in context with production environment. So these tools, they basically monitor your server, they monitor your switches, of course they monitor your applications and any services that you have deployed on your servers. And they generate alerts when something goes wrong. And that's the whole job of monitoring. It is continuously watching, continuously looking at what is running, what is happening, what is going up, what is going down, when is CPU peaking, when is memory peaking, and all that. So that you typically send limits for these all these different parameters, and anytime any of these parameters goes outside of that limit, even more than that or less than that, these monitoring tools usually send out an alert, and these alerts could again be SMS alerts or email alerts, and there are usually people monitoring these monitoring tools to look out for any issues reported. And they also generate alerts when the problem has been resolved. So they work both ways. So Nagios is an open source monitoring tool, and it can even monitor your network services. There's a little diagram here, which is a little too small, but here is Nagios somewhere, what I can read. And status. So these are different devices, I think. No. Yeah, these are different devices to which Nagios is sending the status. There's a browser, there's an SMS, there's an email, and then there's a graph also. And these are different objects that Nagios is basically monitoring. This is an SMTP server. I can read SMTP. This is, I don't know, TCP/IP? No, I don't know, something. Database server. Okay, this is a database server, and this is an application server. This is a switch router. Okay, I can read that now. So these are the different kind of objects. These are different kind of servers that Nagios monitors, and these are the different kind of devices or statuses that it can send. So it helps monitor your CPU usage, your disk usage, and even your system logs. And it uses a plugin script that can be written, in any scripting language actually. If you ask me. So Nagios remote plugin executors are basically agents that allow remote scripts to be executed as well, and these scripts are usually executed to monitor, again, your CPU, disk usage, number of users logged in, who's logged in at what time, logged out at what time, and all these things. So all these monitoring tools work on the concept of polling. So polling is more like, so the NRP agent is a program that will continuously keep polling a machine for certain parameters that are configured in Nagios to be monitored. So this program continuously keeps pinging the server, bringing the program, to keep checking for what it has been asked to check. So in case of logged in users, you keep checking at a, like maybe every 30 seconds or every 1 minute, you keep pinging to see how many users have logged in onto this server, and who are the users who have logged in, what time they logged in, what time they logged out, and things like that. So Nagios poll agents on remote machines. This is what basically it means. Nagios has agent programs that can, help you poll or ping even remote machines. The Nagios Remote Data Processor is an agent that allows flexible data transports, and it uses HTTP and XML protocols to do that. And we're talking about essentially your databases and data server usages, like within, if you have an Oracle database, how many database instances are there, how your load balancing is set up on that, how data is moving between different database servers within Oracle, and how data is moving within the load balancers, and there's always a DRP, there's always a backup with database. So that's why you see me mention DRP as soon as I say the word database. And if there's a backup plan, how's the data moving? How much time did the backup take? Did it take too much time? And why did it take? So it helps you do all those kind of monitoring. The NS client is basically mainly used to monitor Windows machines, and typically when we talk about servers, we end up talking more about Unix or Linux servers. Of course, now with a lot of Microsoft technologies being robust than they
itself, and there are some small checks that needs to be done. So, and by default, Jenkins launches on the port 8080. So let me just open up localhost 8080. There's a small checking that will be done as a part of the installation process, wherein I need to type in a hash key. All right. So there's a very, very simple hash key that gets stored out here. So I'll have to just copy this path. If at all you're running as a WAR file, you would see that in your logs. All right, so this is a simple hash key that gets created every time when you do a Jenkins installation. So as a part of the installation, it just asks you to do this. So if that is not correct, it will crib about it, but this looks good. So it's going ahead. All right, one important part during the installation. So you would need to install some recommended plugins. What happens is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugin and it's got a dependency which is not installed, and you get into all those issues. In order to get rid of that, what Jenkins recommends, there's a bunch of plugins that is already recommended. So just go ahead and blindly click that install recommended plugin. So if you see, there is a whole lot of plugins which are bare essential plugins that is required for Jenkins in order to run properly. So Jenkins, as a part of the installation, would get all these plugins and then install it for you. This is a good combination to kind of begin with. And mind you, at this moment, Jenkins needs lots of bandwidth in terms of network. So in case your network is not so good, few of these plugins would kind of fail. And these plugins are all available on openly or mirrored sites, and sometimes some of them may be down. So do not worry in case some of these plugins kind of fail to install. You'd get an option to kind of retry installing them, but just ensure that at least most or 90-95% of all these plugins are installed without any problems. Let me pause the video here for a minute and then get back once all these plugins are installed. My plugin installation is all good. There was no failures in any of my plugins. So after that, I get to create this first admin user. Again, this is one important point that you got to remember. Give in any username and password, but ensure that you kind of remember that, because it's very hard to get back your username and password in case you forget it. All right, so I'm going to create a very, very simple username and password. Something that I can remember. That's my name, and an email ID is kind of optional, but it doesn't allow me to go ahead in case I don't. So I just give in an admin and I got a password. I remember my password. This is my full name. All right, I say save and finish. All right, that kind of completed my Jenkins installation. It was not that tough, was it? Now that I have my Jenkins installed correctly, let me quickly walk you through some bare minimal configurations that is required. These are kind of a first time configuration that is required. So, and also let me warn you, the UI people to wrap their head around it, specifically the Windows guys. But if at all you're a Java guy, you know how painful it is to write UI in Java, you will kind of appreciate, all the effort that has gone into the UI. Bottom line, UI is a little hard to, wrap your head around it. But once you start using it, possibly you'll start liking it. All right. So let me get into something called as Manage Jenkins. This can be viewed like a main menu for all Jenkins configuration. So I'll get into some of those important ones. Something called as Configure System. Configure System, this is where you kind of put in the configuration for your complete Jenkins instance. Few things to kind of look out for. This is a home directory. This is a Java home where all the configurations, all the workspace, anything and everything regarding Jenkins is stored out here. System message, you want to put in some message on the system, you just type in whatever you want and it's possibly show up somewhere up here on the menu. Number of executors, very, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. You can kind of visualize it like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, number of executors 2 should be good enough. In case at any point in time, if there are multiple jobs that kind of get triggered at the same time, in case the number of executors are less compared to the number of jobs that have woken up, no need to panic because they will all get queued up and eventually Jenkins will get to running those jobs. Just bear in mind that whenever a new job kind of gets triggered, the CPU usage and the memory usage in terms of the disk write is very high on the Jenkins instance. So that's something that you got to kind of keep in mind. All right, but number of executors 2 for my system is kind of good. Label for my Jenkins, I don't want any of these things. Usage, how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this node as much as possible. Quiet period. Each of these options have got some bare minimal help kind of a thing that is out here. By clicking on these question marks, you will get to know as to what are these particular configurations. All right, so this all look good. What I want to show you here is there's something regarding the Docker, timestamps, Git plugin, SVN, email notifications. I don't want that. What I want I want this SMTP server configuration. Remember, I mentioned earlier that I would want Jenkins to be sending out some emails. And what I've done here is I've just configured the SMTP details of my personal email ID. In case you're in an organization, you would have some sort of an email ID that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of send out emails. But in case you want to try it out like me, I have configured my personal email ID, which is on my Gmail, for sending out notifications. So the SMTP server would be smtp.gmail.com. I'm using the SMTP authentication. I've provided my email ID and my password. I'm using the SMTP port, which is 465. And reply to address is the same as mine. I can just send out an email and see if at all this configuration works. Again, Gmail would not allow anybody to send out notifications on your behalf. So you'll have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notifications on your behalf. So I've done already that. I'm just trying to see if I can send a test email with the configurations that I've set in. Yes. All right. So the email configuration looks good. So this is how you configure your your Gmail account in case you want to do that. If not, put in your organization SMTP server details, which are with a valid username and password, and it should all be set. All right, so no other configurations that I'm going to change here. All of these look good. All right, so I come back to Manage Jenkins. Okay, one other thing that I want to kind of go over is the global tool configuration. Imagine this scenario, or look at it this way. Jenkins is a continuous integration server. It doesn't know what kind of a code base it's going to pull in, what kind of a tool set that is required, or what is the code that is going to be unless and until you want to restart Jenkins once in a while. But as a good practice, whenever you do some sort of a big installations or big patches on your Jenkins instance, just ensure that you kind of restart it. Otherwise, there would be a difference in terms of what is installed on the system and what is there on the file system. You would need to flush out few of those settings later on. But for now, these are all very small plugins, so these would run without any problems. But otherwise, if at all there are some plugins which would need a restart, kindly go ahead and restart your Jenkins instance. But for now, I don't need that. It looks good. I've installed the plugin. So where do I see my plugin? I installed the plugin that is specific to the user control or the access control. So let me go into, yes, global security. And I would see this role-based strategy showing up now. All right, so this comes in because of my installation of my role-based plugin. So this is what I would want to enable, because I already have my own database set up. And for the authorization part, in the sense that who can do what, I'm going to install. I've already installed a role-based strategy plugin, and I'm going to enable that strategy. All right, I would say save. Okay, now I've installed the role-based access plugin. I would need to just set it up and check that, I would go ahead and create some roles and ensure that I assign users as per these roles. All right, so let me go to Manage Jenkins. Where is this? Configure global security. Is that where I create my roles? Nope, not here. Yes, manage and assign roles. Okay, again, you would see these options only after you install these plugins. So for now, I've just enabled the plugin. I've enabled role-based access control, and I would go ahead and create some roles for this particular Jenkins instance. So I would say first, manage roles. So I would need to create some roles here, and the roles are at a very high level. These are global roles, and there are some project roles, and there are some slave roles. I'll not get into details of all of these. At a very, very high level, which is a global role, let me just create a role. A role can be kind of visualized like a group. So I would create a role called developer. Typically, the Jenkins instance or the CA instance are kind of owned up or controlled by QA guys. So QA guys would need to provide some sort of limited access to developers. So that's why I'm creating a role called developer, and I'm adding this role at a global role level. So I would say add this here, and you would see this developer role that is there. And each of these options, if you hover over it, you would see some sort of a help on what are these permissions specific to. So what I want is it sounds a little different, but I would want to give very, very little permissions for the developer. So from an administration perspective, I would just want him to have a read kind of a role. Credentials, again, I would just want a view kind of a role. I don't want him to create any agents and all that stuff. That's good for me. For a job, I would want him to just possibly read. I don't want him to build. I don't want him to cancel any jobs. I don't want him to configure any job. I don't even want him to create any job. I would just want him to read few things. I would not give him possibly a role to the workspace as well. I mean, I don't want him to have access to the workspace. I would just want him to read a job or check, have read-only access to the job. Run. No, I don't want him to give him any particular access which will allow him to run any jobs. View, configure, yeah, possibly create, yeah, delete. I don't want read, yes, definitely. And this is the specific role. So what I'm doing, I'm just creating a global role called developer, and I'm giving him very, very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs, or build jobs, or cancel jobs, or configure jobs. At the max, I would just want him to read a job that is already put up there. Okay, so I would save. Now I've created a role. I still don't have any users that is there on the system. So let me go ahead and create some user on the system. That's not here. I would say configure, manage Jenkins, manage users. Okay, let me create a new user. I would call this user as, yeah, developer one sounds good. Some password that I can remember. Okay, his name is developer1 d@d.com or something like that. Okay, so this is the admin with which I kind of configured or brought up the system, and developer one is a user that I have configured. So still have not set any roles for this particular user yet. So I would go to manage Jenkins. I would say manage and assign roles. I would say assign roles. Okay, so if you see, what I'm going to do now is assign a role that is specific to that particular developer. I will find the particular user and assign him the developer role that I've already configured. The role shows up here. I would need to find my user, whoever created, and then assign him to that particular role. So if you remember, the user that I created was developer one. I would add this particular user, and now this particular user, what kind of a role I want him to have, because this is the global role that I had created. So developer, I would assign this developer one to this particular global role, and I would go ahead and save my changes.